Hi guys, so we're going to look at yesterday's notes. We're going to finish up these notes today. Example 10 is an example that has a denominator that you'll notice has two terms. Okay? Whatever your denominator is, two terms in denominator. Whatever your denominator is, if there's only one denominator, that's your LCM. Your LCM is just E plus A. So to clear out this fraction as my first step, remember you always want to clear out the fractions first, you want to multiply by the LCM. So you're going to multiply both sides by E plus A, which should be in parentheses. And what that does is it clears it out of the right side and it moves it onto the left side. So you end up with T times the quantity E plus A equals 2U. And we're solving for A, which is in here. So one thing I could do is distribute, or you could divide by t. Either one works. So let's say I distributed. I would have te plus ta equals 2u. I'm trying to isolate a. I would subtract te on both sides. I get ta equals 2u minus te and divide by t. So a equals 2u minus te all over t. Alternatively, if you decided you wanted to divide, since you have parentheses, you could divide by t. Then you ended up with e plus a equals 2u over t, and then you would just subtract the e, which is separate from this fraction here. So it would just be a equals 2u over t minus e. And these two are equivalent. And you can see that because remember that in the big fraction here, both terms are being divided by t. So the 2u is divided by t, which is here, and then you have te over t, which just cancels out to minus e. Okay, either answer is acceptable. So that's what you do when you have a denominator that's two terms. You just multiply by that denominator. Next, we're going to look at examples where we're factoring out. So in examples where we're factoring out, we're trying to isolate a variable, x in this case, that's in two terms that are not the same, that cannot be combined. They're not like terms. So what we do is we go basically backwards from the distributive property, and we set up, instead of having the two x's as separate terms, we put them outside of parentheses as one term. So I'm bringing down d equals. So I basically set up like a distributive property problem. This is called factoring. I pull the x out and I say, okay, x times what would give me px, and x times what would give me fx. So I'll do it in the next line. I would have x times p would be px, and x times f would be fx. And what that does is it takes your two x terms, which were here and here, and it turns it into just one x so that you could isolate it. All right, and then now once you've done that, your next step is really easy. All you have to do is just divide both sides by what's in the parentheses. So divide by p plus f, divide by p plus f. It cancels those out, and your answer is x equals that big fraction d over p plus f. So x equals d over p plus f. And the parentheses are optional. If you want to put them, you don't need them. Either way is fine. Okay, take a look at example 12. Again, you'll notice you want to isolate a, but there's an a here and there's an a here. You can't isolate it when it's in two places. So what we do is we factor out the a. That means we put it outside of parentheses and we turn it into 1a. And you think to yourself, a times what would give me am, and a times what would give me a. So I'll do it in the next step. A times m is am, and a times 1 is a. And now when you've turned it into 1a, now you could divide both sides by m plus 1, and you're done. A equals 15 over m plus 1. All right. The next one, example 13, has basically the same thing, but with a little extra step. And that extra step is, you'll notice that we're solving for x. There are two terms with x, but they're on opposite sides of the equal sign. So the first thing you want to do is get your x terms on the same side of the equal sign. on the same side of the equation. That's your first step. I'll put a 1 for step 1. So I might subtract cx from both sides, or you could subtract bx. I have bx minus cx plus 2 equals negative 12. And then I want to subtract 2, because I don't want the 2 on that side. I just want the x terms on one side. So that equals negative 14. Once you get your x terms on the same side, now you factor out the x. So step 2 is factor out the x. And that's again because you have an x term here and here. You can't isolate it if it's in two places. So you take it and put it outside of parentheses like this. So x times b is bx, x times negative c is negative cx. And now you just divide. Divide by b minus c, divide by b minus c, x equals negative 14 over b minus c. Now, if you had started out by subtracting bx on both sides like that, then you would have gotten basically everything on the opposite side of the equal sign. And you would have gotten x equals, and you would have gotten a positive 14, and instead of b minus c, you would have gotten c minus b. Those are equivalent. Same answer. Okay, at this point you might want to pause the video and try example 14 on your own. And I'll go over it now. I'm going to solve for b, so I'm going to first distribute the a. I have ab minus ad equals bx plus c. I'm solving for b, so I'm going to try to get my b terms, which are here and here. I'm going to try to get them on the same side of the equal sign. So I might subtract bx on both sides. ab minus bx minus ad equals c. And then I'd want to move the ad over, because that one doesn't have a b in it. I'm trying to solve for b. So I now have ab minus bx equals c plus ad. This is the point where I notice that there's a b here and a b here. It's in two terms that I can't combine, so I factor it out. I put the b on the outside of the parentheses. And I say to myself, b times what two terms would give me ab minus bx? Well, b times a and b times negative x. And now I just divide. Divide by a minus x, divide by a minus x, and I have b equals c plus ad over a minus x. Alright, so hopefully these notes will help you to work on tonight's homework, and we'll go over it tomorrow. Okay, bye.